Okay, so we are live. Welcome to the stream, ladies and gentlemen. Waiting. Okay. No, let's get started. I wouldn't want to keep you waiting. I was at the softball game, and I'm not sure that the other team scored a point. That was how good they did. So that was really impressive. Let's get started with the work. Sorry to keep you guys waiting. But we are ready to rock and roll Aura. Okay, so our first problem. Just want to check my stream health here. Make sure everything is hunky-dory, as they say. And then we will start directly, ladies and gentlemen. Appreciate everybody that's joining the stream right now. We are currently looking at the homework on page 558, number 1. But I'll also take suggestions if you've got something you want me to work. Okay. Okay, here we go. So let's see what they want us to do in this first problem. They want us to solve this equation by graphing. You guys are going to let me know if the sound is too loud, I hope. So the very first problem is x squared plus 3x minus 10 equals 0. Well, let's do it. If that's what they want us to do, let's do it. Let's graph this thing. So this is going to be, was it number 1? It was literally number 1. Okay, number 1. Gotcha. Wow. I better zoom out a little bit. That 1 looks huge. Okay, there, number 1. And then we'll paste this guy here. Okay, x squared plus 3x minus 10 equals 0. I like to rewrite it. So I'll rewrite it. X squared plus 3x minus 10 equals 0. My first question is this in standard form? Yes. Okay. Let's remind ourselves that's ax squared plus bx plus c equals 0. If it is in standard form, and indeed it is in standard form, we're going to identify a, b, and c. Well, a is 1 because there's a 1 in front of the x squared. B is 3, and c is negative 10. Because the leading coefficient of the quadratic term is 1, we don't have to find the master product because 1 times negative 10 is negative 10. So what we're looking for are two numbers that add to equal 3 and multiply to equal negative 10. So we're going to break this down. 10 is 1 times 10. 10 is also 2 times 5. Okay. And here's the key point. Because C is negative, we know that the signs will be different. Okay? That is a key thing. You must, in fact, I'm just going to write it. Because C is negative 10. Okay, negative. C tells us the signs will be different. Okay, once you know that, then your attention shifts to the B variable, or the B coefficient. I don't like that color. The B coefficient is a positive number. So, because B is a positive number, we know that the biggest number, the biggest factor is positive. So what we can do here is just go into our factor pairs and put a plus sign next to the big number and a minus sign next to the little number. Okay, so it's easily this factor pair right here, since when you add those together, you get 3, and when you multiply them, you get negative 10. So, negative 2 and 5, negative 2 and 5. So, open parentheses, close parentheses, open parentheses, close parentheses, equals 0. Inside, we have x, and then our biggest term is positive, so we put plus 5 and minus 2. Okay, set both of these factors equal to 0 and solve. So x equals negative 5 and x equals 2. Okay. Remember what that means. These are the x-intercepts. They're also the zeros. Okay. Now we need to identify the y-intercept, and the y-intercept is the C term. So here's what we know. Let's make a little list of what we know. We know that the y-int is located at 0, negative 10. We know that a is greater than 0, so the graph is going to be upward sloping, which means that we'll have a minimum. And we know that we have two real solutions. Okay. And those are the x-ints located at negative 5, 0 and 2, 0. Now we need to find the vertex. Okay? This is the thing that we learned today. Remember, the x-coordinate of the vertex is equal to negative b over 2a. Well, we identified b as 3 and a is 1, so that would be negative 3 over 2 times 1, which is negative 3 over 2, which equals negative 1.5. But for our purposes, we actually need this version of the x-coordinate, because now we need to evaluate at negative 3 over 2. And what do I mean by evaluate? What I mean is, ladies and gentlemen, we need to plug negative 3 over 2 everywhere we see an x. So we're going to rewrite x squared plus 3x minus 10, but I'm going to use function notation. F of x equals x squared plus 3x minus 10. And I'm now going to evaluate that function at x sub v. Okay. So everywhere I had an x before, I'm now going to have open parentheses, and inside those open parentheses, I'm going to write x sub v. Well, we already know what x sub v is. It's negative 3 over 2. So let's substitute in the actual coordinate in fraction form. And remember, guys, I told you I was going to show you how to do these really fast, and I will. But before we get to have fun and just blast through them with the calculator, you need to understand how to do it by hand. Because if you learn how to do this by hand, then you'll understand when the calculator is giving you nonsense information. And what we're about to do right now is absolutely one of those things where the calculator will mess it up. I'll prove it to you in a second. Well, so when we're dealing with this, we're taking a fraction and we're squaring the fraction. You need to distribute that 2 to both the numerator and denominator. So you have to square the numerator and square the denominator. Okay, so negative 3 over 2 squared is actually negative 3 squared over 2 squared. And here's where I want to show you why the calculator is something you cannot rely on. Look what happens when I square negative 3. It tells me the answer is negative 9. Ladies and gentlemen, that is outright false. Okay? That is not true. Okay? What you would have to do to get the calculator to not lie to you is to put the negative 3 in parentheses and then square that, and now it'll tell you it's positive 9. Here's my advice. Don't use the calculator to do something like that because you're going to mess it up. Just use your mind. Anything squared is positive. All squares are positive. All even numbered exponents are positive. Anyway, so now what we're going to do is multiply this 3 times this negative 3 right here, and we're going to put the whole thing over 2. So I'll say plus 3 times negative 3 all over 2 minus 10. Okay. Now we know negative 3 squared is positive 9. Over 2 squared is positive 4. Plus 3 times negative 3 is negative 9 over 2. Minus, and I'm going to do 10 over 1 here because I know what's coming next. I have to find the lowest common denominator, which in this case is going to be 4. So I need to go through and multiply my negative 9 over 2 by 2 over 2, so I have a denominator of 4. And my 10 needs to be multiplied by 4 over 4, so I have a denominator of 4. So let's simplify that. 9 over 4 plus negative 18 over 4, okay, plus negative 40 over 4. Well, the wonderful thing about this is now I can just write 9 minus 18 minus 40 all over 4. Because when they have a common denominator like that, I'm able to write everything over one denominator. Okay? And just remember that all along, this is f of negative 3 over 2. This means ditto, or the same thing. Okay? So 9 minus 18 is negative 9 minus 40 over 4. Don't like that at all. Let's make it look good. We're going to do the problem. Let's do it right. So negative 9 minus 40 over 4. And now I do negative 9 minus 40 is negative 49 over 4. Well, 4 goes into 49 12 times. That's 12 times 4 is 48 with 1 as a remainder. So negative 12 and 1/4, or negative 12.25. So this, just so you understand, this is the y coordinate of the vertex. Or we could say y sub v. So what I want you to do is take this number, or this number, whatever, and let's bring it back up and pair it up with the x coordinate of the vertex. Okay, so we have the x coordinate is negative 3 over 2, and the y coordinate is negative 49 over 4. So if my vertex is written as x sub v, comma, y sub v, and x sub v is negative 3 over 2, and y sub v is negative 49 over 4, then my vertex is located at negative 3 over 2, comma, negative 49 over 4. Now, plotting that on a coordinate plane isn't going to work very well. So we should probably write our vertex in decimal form. So we would say the vertex is at negative 1.5, comma, negative 12.25. Okay? So now we have to draw a graph. And when we draw that graph, you have to look at a lot of things. You got to look at your y-intercept. Okay, you need to have at least negative 10 on the y-axis. You need to look at the range of values here of your zeros. So you got to go negative 5 and all the way out to positive 2. And then your vertex, which is the minimum, goes all the way down to negative 12. So what we need to do is we need to kind of mess with this graph kind of make it bigger and also make it go down farther. Like that. Now let's label the graph. Okay, so we'll say negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 11, negative 12, negative 13. So negative 1, negative 3, negative 5, negative 7, negative 9, negative 11, negative 13. Now I got to label the x-axis. So we'll say 1, 2, 3. Well, no, I don't want to do it that way. I'll make this 1, and then I'll make this 2, and I'll make this 3, like that. We'll space it out more. Okay, so that's negative 1 there, and there's negative 2. There's negative 3. There's negative 4. And there's negative 5. Okay. Let's put arrowheads and label our graph correctly. Okay, so we're going to label all of our points now. First, we're going to label our y-intercept at 0, negative 10. Okay. So here's the y-intercept right here. And we'll label both of our solutions. Okay. Which is x equals -5 and x equals 2. Okay. So our solutions are, we have an x-int at -5, 0. That would be here. And we have an x-int at, I just want to make sure I get it right, +2. Okay. 2, 0. So I'm going to go over here to 2 and put a dot there. Now I need to label 5 points before I can graph this thing. So now we're going to label the vertex. And we're going to start by labeling the x coordinate of the vertex. And here's something you need to learn. The axis of symmetry is x sub v. Okay, so the x coordinate of the vertex is the axis of symmetry. And that means that the axis of symmetry is -1.5. So what I'm going to do now is label -1.5 with a dotted vertical line. Should be right there. This is what you need to be doing. If you think this is hard, all I can tell you is I didn't invent the math. Okay, this is what the mathematics is. I'm just trying to teach you how to do it. So we plotted the axis of symmetry. And what that means is that everything will be mirrored on either side of the axis of symmetry. So now we need to plot the vertex. Well, we know where the x value is. This is it here. So the y value is going to lie somewhere along this axis of symmetry. And where it's going to lie is at -12.25. So if we go down here to -12, a little bit below it will be -12.25. So about right there would be the axis of, would be the vertex. Okay, so there's the vertex. Okay. Here's the y-intercept. Okay. This guy right here is an x-intercept. There's another x-intercept. So we're only missing one point, and that is the point of reflection. Okay. So I need to use the axis of symmetry information to talk to you about the point of reflection. What it means is you are going to measure the distance that, here's what I'm going to say. It is the horizontal distance from the x-coordinate of the y-intercept, okay, which in this case would be 0, and x sub v. Okay, so the horizontal distance from the x-coordinate of the y-intercept 0 to x sub v, which is at -1.5, is -1.5. Okay. Now what I want you to do is take the absolute value of that number. The absolute value of -1.5 is 1.5. Okay. Now, add 1.5 to 1.5. And that's going to give you the x coordinate of the point of reflection. So 1.5 plus 1.5 equals 3. So the x coordinate of the point of reflection equals 3, 0. Pardon me, equals 3. The y coordinate of the point of reflection equals the y int. All right. Here's what this looks like visually. You bring your ruler right up to that y-intercept. And this horizontal distance right here is 1.5 units. All right. Now you're going to move 1.5 units to the right of that. Right about here. See, what you're going to do is get your ruler centered there at -3 and come down. Okay, and you're going to have these, you're going to get these points to intersect one another right here. Now, the way I drew my graph, it doesn't look like it's perfectly reflected, but that's how you do it. So, -3, comma, -10. That is the point of reflection. Well, now you've got 5 points plotted. Look, 1, 2, 3, 4, 5. Once you plot 5 points, you're able to graph the quadratic. So what you got to do to graph the quadratic is create a mirror shape that is mirrored on either side of the axis of symmetry. So here's what that would look like. You just kind of connect the dots. This is the hardest part down here. You want to connect these dots, obviously not like that. You want to connect these dots like this and make a hoop shape like that. Okay, and then it curves up to hit that point there. The same thing happens on the left side. It curves up and it hits that point there. Try to be real artistic about it. And now you have to create the points going off into infinity. So artists will get this, but I want you to kind of shade it in. Watch how I do this. You want the thing to look parabolic. Okay, so I'm just gently trying to graze that line in such a way that it appears to just kind of slope off into infinity like that, okay? Then you can go back and make it look, but you want it to look like a very smooth curve. Put arrowheads on the end, and now the best as you can, reflect that image on the other side of the axis of symmetry. And that's the hard part, is to make it reflected, okay? And that's why I come in here. It really works best with a pencil, okay? In fact, I might use a pencil, the pencil pen, the pencil tool on the next one, okay? Because you want to, artists will understand, you want to brush the line in very gently, okay? Instead of just ramming the pen down on the paper, because it won't look right, okay? So that is a completed answer right there. And this is the work that went into it. Let me move some of this work up here. I want to move this work up here Whoa, whoa, whoa. Come back down here. I want it to go right there. Oh, man. It cut the top of the thing off. Okay, I'll just put that back. So I got to put these back. The arrowheads. And then I got to put back this parentheses. Let me zoom in on it to fix it. Now, some of you might be thinking, you have got to be kidding me. Are you telling me that I have to do this every time? And let me answer that question for you the way that my teacher answered it for me. Yes. Okay. Look, there's going to be a range of opinions about this kind of a problem. To me, and guys, this might be why I'm a math teacher, and I mean this honestly, I find this very fun. Okay? So, if you find this to be fun, that whole process there, that whole analytical process, then math is for you. If you find this to be extremely tedious and boring, and where you think, if this is what I have to do in this class, then I quit. If that's your reaction, or I guess I'm going to fail this chapter test because I'm not going to put in the time to understand how to do this, then my answer to you is, that doesn't mean you're a bad person, okay? Look, it just means that you don't like math, all right? Because this graphing quadratic equations is one of those things that separates people who like math from people who don't like math. And I don't know about you, but I also find this process to be very artistic. Okay? So to me, there's a kind of beauty to what we're looking at here. So if you find that beauty and harmony in what we just did, then math is for you, and you should really start to focus on this. But if you hated this, then I want to take this opportunity to show you how to get done with the problem as soon as possible. Okay, as quickly as possible. So that's what we're going to do in the next problem. We're going to literally go in the opposite direction, and we're going to solve it on the calculator with minimal effort. All right? But that is how you do it by hand. Okay, so let's move in here. We did number 1. And now we're going to do number 4. But before and I'm going to get number 4 set up. Come on now. Okay, so I want to put number 4 here. Hang on a second. I guess I'll have to put it down here. Number 4. Okay, number 4. Whoa. X squared plus 12 equals negative 8x. Okay, this is not in standard form. So what I want you to do while I'm checking the stream health in your own work is try to rearrange this equation to make it look like this. Okay? So work on that while I'm checking stream health. What is going on in the chat? Yeah, this is the homework for today. Wow, there's been a lot of chatting. Okay, I think I'm getting caught up now. Okay. Oh, is that the song that's playing? Oh, yeah. Okay. So, did you enjoy number 1? Okay, so now we'll do number 4. You just have to check the stream health. "29 playbacks, 9 minutes and 30 seconds. Yeah, could be better, honestly. Okay. You did, and you did. Good. Excellent. Oh, thank you. Thank you to the gentleman who reminded me of something. All right. Okay. All right, I'm just trying to look through some comments here. Hang on, I got to text a parent real quick. Okay. Right. Okay. So I'm back now. Let me ask the people who are actually watching this a question. Okay, so in comment section, I'm going to ask you a question. Do you want me to solve this by hand or on the calculator? Okay, Jasmine. Done. There we go. So, if we're going to solve it by hand, the very first thing we have to do is get it in standard form. So I'll move 8x to both sides, or to the left side by adding it to both sides. And I'm going to try to go a little bit faster, okay? You guys tell me if I move too fast for you. So now x squared plus 8x plus 12 equals 0. That means my a value is 1, my b value is 8, and my c value is 12. Because c is positive, they have the same signs. This is my factors now. And because because b is positive, they both have pluses. So what I'm looking for is something that's going to have this template. Okay? So what we have to do is find two numbers that add to equal 8 and multiply to equal 12. Okay? So they'd be 6 and 2. This one was easy. 6 plus 2 is 8, and 6 times 2 is 12. So now we set those factors equal to 0 and solve for x twice. Okay, so these are my two solutions, and now I'm going to find the x coordinate of the vertex, negative b over 2a. That's negative 8 over 2, which is negative 4. And then I'm going to evaluate my function at negative 4. Okay, so 16 minus 32 plus 12 equals 0. Well, not equals 0. So now we'll figure this out. X sub v equals this, and x sub v equals this. So the x coordinate of the vertex equals negative 16 plus 12. So that's equal to negative 4. Oh, sorry. I meant the whole time I was writing x sub v, I meant to be writing y sub v. I apologize. So here's the good news. We found the vertex. It's located at negative 4, comma negative 4. The thing that was confusing me is that both points were the same, so I was a little confused. So here's, I just want to make a note that my vertex is located at negative 4, comma negative 4. If that's true, then my axis of symmetry is located at x equals negative 4. Okay? So where will my point of reflection be? It's going to be at, so the x coordinate of the point of reflection is going to be at negative 4 minus 4. Okay, so that would be at negative 8. And the y coordinate of the point of reflection is equal to the y-intercept, the y value of the y-intercept. The y-intercept is 12. Okay, so that point of reflection that we need to find is going to be located at negative 8, comma 12. Okay, so here's all the information we need to graph this. We have an x-intercept at negative 6, comma 0. And we have an x-intercept at negative 2, comma 0. We have a y-intercept at 0, comma 12. We have a point of reflection located at negative 8, comma 12. And we have our vertex located at negative 4, comma 4. Negative 4. Negative 4, comma negative 4. The only thing you need to know now is which direction does the line slope. So we say because A is greater than 0, it is an upward sloping curve like this. And the vertex represents a minimum. So without even graphing this, I can tell you that we already know the range. Okay? The range is equal to the minimum to infinity. Okay, so how would I write that in like normal language? So in other words, what values can y be? So let's write the range in inequality notation now. The minimum is at the y coordinate of the vertex. Okay, so where you're going to get this information is from right here. Okay. And what we're going to do is write negative 4 is less than or equal to y is less than or equal to infinity. Now the domain of all quadratic graphs, I should say functions, is negative infinity, less than or equal to x, less than or equal to infinity. So you need every single shred of this information before you graph your quadratic functions. Okay, what is that? 8 pieces of information. And your 5 points that you're going to graph are right here. So these are your 5 points. So let's do this. Let's create a graph from scratch. And plot all that information. Okay, I'm going to need to move that up. Okay. And we'll put the graph down here where we can kind of see everything all at once. So let's think about the dimensions of our graph. My x, oops. Here are the dimensions of my graph. I need to be at least at -6 and all the way over to -2. So I'm really only in quadrant 2 and 3 when I'm graphing this. And then on my y-intercept, I am at 12. So that's going to be real high in quadrant 1 and 2. And then down, my vertex is located at -4. So that would be quadrant 3. So my focus is going to be kind of in quadrants 2 and 3. All right. So those are some of the things I'm looking at here. So what I think I'm going to make my dimensions are for x, for the x-axis. Oh, I keep making this purple. I'm sorry. It looks black. Okay, for the x-axis, I think I'm going to go from 0 to -8 for x. And then for y, I'll go from -6 up to 14. Okay. So now let's insert the shape. And we'll call this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So right there at 0, 12, that is my y-intercept. See that point that I just plotted there? And now what I'll do is go to -6 on the x, and we'll do a different scale for x, because this was 1, 3, 5, 7, 9, 11. Here what I'll do is 1.5, -1. 0.5, -2. 0.5, -3. 0.5, -4. 0.5, -5. 0.5, -6. Okay. I said I was going to go to -8, but I'm not. I'm just going to do this. So now I've got one here. And then the other one's at -2. And now I need to go down 4. Down 1, 2, 3, 4. And at -4, comma, -4, I have my vertex. So right here is my vertex. Now my point of reflection, ladies and gentlemen, is going to actually be covered up by where I wrote these dimensions. So I'm going to erase those so that this looks really nice. Okay, first I'm going to plot my axis of symmetry as a dotted vertical line passing through x equals -4. And we'll plot this axis in a light color because it's really not part of the graph. It's just a visual guide. And so I said that the point of reflection would be located at -8, 12. I do have to plot -8, Dumbo. So I'm actually going to need to extend this graph out a little bit. And that happens quite a bit where you didn't make it long enough. So that was -6, -7, -8. Okay, so now I'm going to plot my point of reflection, which was at -8, 12. So that would be like right there. Okay. So now we've got all 5 points plotted. Okay. So now we can use our magic color. And oh, I said I was going to use a pencil this time, didn't I? So let's use pencil, and I'll go in with gray. And I'm going to use a very fine tip to sketch it in. And we'll try to sketch this in, so you can see what I mean. So this part, guys, when you're down here making this little curve, this is really the hard part from an artistic perspective. Because what you want you want it to be a very smooth curve. See what I'm doing there? Just these light brush strokes. So the line is just kind of appearing. Let me zoom in a little bit so you can see what I'm doing. This is kind of what somebody would do with a pencil. All right, it's not as easy here on a, but you really don't know. You kind of have to let your hand kind of just tell you what to do. So it's really an artistic process, okay? So don't rush this part. Okay, maybe that. And then we'll come in here and then do the same thing. Okay, so I'm not talking because I'm trying to concentrate on this. Okay, so it's just kind of, it's coming in now a little bit. So you would be doing this with an actual pencil. That would be recommended anyway. And I guarantee you there are artistic people who are in our class who are going to be producing much prettier graphs than me. Jasmine, you're probably one of them, okay? So now that I've got it kind of sketched in, I can go in with the finishing stroke here. There you go. Okay, put those arrowheads on the end. And that is the graph. Yeah, this is the textbook homework. Who is Dr. 3 Marty? Wow, everybody wanted me to do it by hand. I hope you guys... Good. Who's... Yes. Who is this? Oh, hey, Kobe. Oh, hey, Kobe. Welcome. I didn't recognize it. I got it now. Like Dr. Martin. I got you. Cool. Yes, this is the textbook homework. We just did number 4. Okay, so this is number 4 from the textbook. I'll zoom in on that a little bit. So I'm going to take a little break now. I've been working for an hour, I think. Let me check the... Yeah, 1 hour and 5 minutes. So let's take a break, guys. Let me just say this before we sign off. I mean, for the break, I'm not signing off. This is not a fast process. There is no, like, if you want to do this by hand, you have to kind of just slow your mind down and stop trying to rush through the work. And look, you're getting to a level in the mathematics where you need to come to me and show me, hey, look, I did 2 of these problems, right? It took me an hour. I didn't have time to finish all 9 of them or 10 of them. And I'll say, okay, let me see the work, and I'll look at it. And if it looks like you can demonstrate to me that you know how to do it, maybe we can shorten the assignment. But I need you guys to show me that you can do this. And so that's why we have to practice very slowly, because I don't want to leave anyone behind. Honestly, I don't. And we really should try the next one when we come back. We should try it using the calculator, since I'm going to tell you guys something. About 80% of the folks who are having to do this assignment would really prefer to do it on the calculator. Not everybody, different strokes for different folks. Math is a kind of unique thing where everybody has to take it, but only a few people actually enjoy taking it. And if you're in this chat right now, I imagine you might be one of those people who enjoys it. Maybe not. But anyway, when I come back from the break, I will show you exclusively on the calculator how to do this, okay? So that I can prove to you that where it takes us 1 hour to do 2 problems by hand, on the calculator, we could literally do it in less than 30 seconds. Okay, I'll prove that to you when we get back. Yeah, calculator next. Let's take about a 5-minute break. Okay. And I'll just leave this work here so people can see what we did. In case they join in, they can get caught up. And I'll be back in like 5 minutes. Okay, ladies and gentlemen, I am back, and we will get started. Just check the stream health. All right, we have 10 people watching. Awesome. I am back. So everything looks good, and we're going to fly through these problems, okay? Because I know that really, having done a couple of them, we kind of get the idea, and we're ready to just move on. We'll come back to doing the really very artistic work later. So we did number 4. Now we're going to show you guys how to fly, okay? So we taught you how to build the airplane. Let's teach you how to fly the airplane. So down here in these problems, numbers 10, 11, 12, 17, and 19, I'll see how many we do using the calculator. Let's work on number 10 right now, okay? So what we're going to do is put x squared plus 7x plus 14 in the calculator. So if you have one of those emulators installed on your phone, open it up now. If you're watching this on your phone, I understand that you won't be able to do it, but I will recommend that you try. So let's pull it up, hit second plus 7, 1, 2. And then go to y equals, and we're going to stick x squared plus 7x plus 14 in there. X squared plus 7x plus 14. Remember I said it was going to take less than 30 seconds? There it is. Okay? Did I write that correctly? X squared plus 7x plus 14. Yep. The reason I solved this one this way instead of doing it on paper is because, do you notice something strange about this picture? Let me show you what's strange about this picture. I'm going to capture this and throw it into OneNote. X squared plus 7x plus 14 equals 0. Okay. This is number, what is this, number 10? Yeah. So we'll do number 10 here. This is still purple. Change this to black. Number 10 was x squared plus 7x plus 14 equals 0. Let me paste this picture in here. So, notice that this never crosses. This is a problem. Never crosses the x-axis. You see that? So we say this equation, or this quadratic equation, has no real roots. All right. But we still have to figure out the domain and range and vertex and all that good stuff. But basically, that would be your answer. Now, if somebody said, what is the vertex of this graph? Okay. We can find that on the calculator. Let me show you how to do that. Hit second trace, minimum. And then set the left bound. Wait till you see this guy, this little dude pop into place. Oh, I'm going the wrong direction. Sorry. I need to go negative. Here we go. It's going to pop in now. Here it is. The left bound of the minimum is going to be right there. And the right bound of the minimum is right there. So the minimum is at negative 3.5 comma 1.75. So when you want to find the vertex, you use second trace minimum. So let's write this down. Vertex. Second trace minimum. All right. Let's paste this little part of that graph, that output in there. So the vertex is located at negative 3.5 comma 1.75. We might need to identify the y-intercept, which is something we can do just by looking at the equation itself. That's 14. So we could say the y-intercept is located at 0, comma 14. What else do they want to know? The domain. Okay, remember the domain is negative infinity less than or equal to x less than or equal to positive infinity. This is also known as all real numbers. Okay, I'm a little bit worried about this song, so I'm going to change this information. Let me get that. Let me get a different NCS going on here. Gaming music 1 hour. Let's find that NCS mix. I think this is it. Here we go. Yep. Oops. So what's the range? Remember, the range is if it's an upward sloping line, the range is the minimum y value it can be all the way up to infinity. So the range is this value here. Here, let me just so we'd say the range is 1.75 less than or equal to y less than or equal to infinity. Okay? Because if it's an upward sloping line, the line goes off into infinity in the vertical direction, but it can't go any lower than 1.75. Okay? It can't go any lower than 1.75. You can say this would be the bottom possible value for y, and that's 1.75, but it can go up to infinity. So that's why the range is 1.75 to infinity. Okay? I can't think of anything else they might want. So that's how you do number 10 in like 2 seconds. Now, what I want to show you now, since we are working on this quickly, and we're not going to spend nearly as much time, I want to show you how to answer a simple question. You ready? Here's a question you might want to know. How can I quickly check if my quadratic equation will have real solutions / x-intercepts? How can I possibly know that? Well, there's a great tool called the discriminant. Okay, the discriminant. And it's a little formula. It is the square root of b squared minus 4 times a times c. Okay, so here's how you evaluate this. If the discriminant is negative, then there are imaginary roots. Okay? If it's positive, then you will have two x-intercepts. Okay, so if the discriminant is negative, you will have no x-ints. So let's evaluate the discriminant of this quadratic. So remember, for this quadratic, x squared plus 7x plus 14. Okay, a equals 1, b equals 7, and c equals 14. So let's take the square root of b squared, which would be 7 squared, minus 4 times a times c, which is 14. Order of operations is very important here. So let's just keep evaluating this. Well, 7 squared is 49. And then we have minus, and then we have 4 times 1 times 14, so we need to do 14 times 4. Okay, that's 1656. So it's 49 minus 56. Okay, so here's the deal. 49 minus 56 is negative 7. Okay, so if you take the square root of negative 7, watch what happens. It says error, non-real answers. All right, see that? Let's do it again. Take the square root of negative 7, error, non-real answers. Okay. Now the way you would actually do this is you would call this, if you wanted to like get ahead, you would say the square root of negative 7 is really the square root of negative 1 times the square root of 7. And there's a rule that says the square root of negative 1 equals the imaginary number I. Okay? So this would be the discriminant evaluates out to I square root 7. Okay? In other words, therefore, no real solutions for this quadratic equation. In other words, no x-ints. And that's how you can figure that out by hand, if you're interested in doing that. But just putting it into the graph is enough. You cannot fully trust the calculator, right? Okay, just checking some comments, making sure everything's looking good. Right, and the calculator, -3 times -3 would be -9. So -3 squared in the calculator, -9, that's false, right? So the calculator will lie to you. You got to put the parentheses first, exactly. Okay, so that's how you do number 10. And there was a request to do some of the problems from CUDA. But, and I'll get to those, Kobe, but I feel like we have to get these done first. So I'm going to show you how to do these very quickly. So we did number 10, and now we'll do number 11, x squared plus 2x minus 24. What? Oh, this is when I was looking at delta math. Hang on a second. Get stranger things off of there. There's the CUDA. We'll get to that in a second, okay? Okay. So, let's put in x squared plus 2x minus 24 into the calculator. Second plus 712. Oops, I guess I hit something wrong. Second plus 712. Go to y equals and just stick this in. X squared plus 2x minus 24. X squared plus 2x minus 24. Graph it. It has two real solutions. So you see that right away? But we can't see the bottom of the, we can't see the vertex. So I want to zoom out. Now I can see the vertex. If I zoom in, I can actually see what those solutions are. But since I know they cross at hash marks, I can actually look at second graph and find out where y is 0. Okay, y is 0 at 4. So one of my solutions is 4. Y is also 0 at -6. So 4 and -6 are my solutions. For number 11 here. Okay, so x squared plus 2x minus 24 equals 0. Our calculator is telling us there are solutions at -6 and at 4 because that's where y is 0. So my x ints are -6, 0 and 4, 0. What's my vertex? Okay, this is an upward sloping curve, so we're going to look at the minimum. So second trace 3 will get you minimum, and you want to go to the left and then to the right, and it'll tell you the minimum is at what appears to be -1, -25. So the vertex is at -1, -25. That was easy. What is the domain? Okay, the domain is all real numbers for every quadratic. All real numbers, unless you have some other information, you're always going to put all real numbers for the domain. What is the range? Well, the range, remember, if it's because it's an upward sloping line, we have a minimum as our vertex point. So we need the y value of the vertex, and that's going to be the low end of the range. So that would be negative 25 less than or equal to y less than or equal to infinity. What's the y-intercept? It's negative 24, right? Or you could say 0, comma, negative 24. So we did all that. We should probably just capture a picture of the graph. And just put it in here. Okay. And we'll just identify these points here. This must be negative 6, comma, 0. And this must be 4, comma, 0. If you zoom in, you can actually see that. Okay, you can actually count 1, 2, 3, 4, 5, 6. So that's negative 6. 1, 2, 3, 4. That's positive 4. Okay. All right. I kind of feel like you guys understand how to do this. I kind of want to show you either some delta math. Okay, we did number 11. Or the CUDA, I guess I could show you. I tell you what, the rest of these are all pretty simple. I could show you how to do them by hand. Let me ask the crowd. What do you all want me to do now? Delta, CUDA, textbook, or just stop? And finish tomorrow in class. Let's do more textbook. Okay, Jonathan, let's do this. Okay, wait. Does everybody kind of wants to stop, huh? Can we still stay in the video? It's best so our classmates don't fall behind. Okay, Jasmine has made a good point. She made a strong point. Okay, guys. Let's end it here. See you all tomorrow. And thank you for joining the stream. Yeah, that's true. Tomorrow is a catch-up day. Bye, everybody. Yes. Okay, we'll end the live stream here. Thanks again for joining. It was my pleasure to work with you guys as always. And we'll just terminate the live stream right here. Oh, thank you, Jasmine. You're the best student ever. Appreciate it. Bye, guys. Have a nice night. I'm out.